problem number 1, part A. Alright, so I'm going to read out the answer and then I'm going to assume I'll need to work it, but either way. So you get 1 point for your derivative, 1 point for the answer. So if you get your answer right, you probably showed the derivative out correctly. The answer should have been 20. Do I need to do that one?
Yeah. I got 35.
You probably did. Did you do 7 times 5, like at the very end?
Yes.
Okay, you used the wrong number in your chart, is all. So you used F instead of F prime. But that's fine. I'll work it out real quick. It's a pretty easy one.
Oh, really? That's all I did?
I'm assuming that's about the only way I could see you getting that. F of x squared minus x.
F.
So you have f of x squared minus x. We want f prime, or sorry, g prime. So that's g of x.
Oh, okay, that makes sense.
So remember, this is a quotient, or a chain rule. So derivative of the outside, leave the inside alone, times derivative of the inside. Okay, and then we're going to plug in, what value is it? 3. So then you plug in 3.
Yes, 3. So confused.
What are you not confused, Valeria?
That's not funny.
It wasn't meant to be funny.
I know. It's okay.
What is f prime of 6?
Donald. Update on Harley Kate. She's been camping all week, so she hasn't had access to any of her school stuff.
Oh, okay.
So she's setting everything up today, and then she'll be here, I guess, next week.
Well, yeah, it's expected everybody will be here next week.
Yeah.
So we'll see.
So you didn't do homework.
I have a question about taking the derivative in the first place.
Okay.
I don't. So is the f on the outside just like as if it was like a constant? I don't understand why you leave it like that.
Because it's f of x. So like if I want the derivative of f of x, it's f prime of x. But instead of it being x, we have x squared minus x on the inside of that function.
Wait, I can't hear you.
I can't help that.
Oh wait, never mind. I hear you now.
It's because it's a function, sweetie. F is a function. F of x squared minus x.
Okay, so then you plug in. Okay.
And then whatever f prime of 6 is, I forget what the.
Understand.
I think it's supposed to be what, 4?
Yeah. Okay.
So 20. So at that point, just multiply, you're done. So pretty easy, 2 points.
If I knew how to take the derivative, that would have been quite easy.
Yes, I kind of envision some of the AP tests being stuff like this, to where it's not super difficult. They're probably going to have some points built in like this one, to be honest. It's definitely what I envision. All right, part B, I'm going to assume I need to do, but just to give the answer so you can check, see if you got the answer right. F double prime of 0 should be equal to -5.
Can you can you take the derivative again for me really fast?
I'm going to, yeah.
Okay, good.
Alright, so whoever's eating, Deborah.
I don't know what you're talking about.
So you take the derivative. When we take the derivative this time, not only do we have a chain rule, we also have the product rule, so you got to be careful. So derivative of the first one times the second one, so you get f double prime of x squared minus x times 2x minus 1. But since we already have one of those there, it's going to become squared. Plus the derivative of the second one times the first one, so 2 f prime of x squared minus x. And they've given us the nice lovely fact that g double prime of 0 is -1. So you just do -1 is equal to f double prime of plug in 0, I get 0, times -1 squared plus 2 times f prime of 0. So just plug in 0 everywhere. And they told us that g double prime of 0 is equal to -1.
How'd that become squared? What?
Because there was one there already. And when I take the derivative of this, I get another 2x plus 1, or 2x minus 1 from taking the derivative of the inside. So you have to be careful.
Oh.
What's f prime of 0, somebody from the chart? Or I'll just walk over there.
I think it's 2.
It's 2.
It's 2.
Thank you. So you get 4, so you get -5 is equal to f double prime of 0, because -1 squared is... that's right. Any questions there? Alright, looking at part C, as soon as you see a statement that looks like that, what are we automatically going to be using? One of two things.
The IVT.
Or...
The... Actually...
So what's the other one? We have IVT or...
Is it Rolle's theorem?
No.
Yeah?
No.
No?
The FPC?
No.
Well,
MVT? Is that what it's called?
Kayla, you've unmuted. Do you have an answer?
I was gonna say MBT.
That is correct. I wanted to give you the chance to talk. I didn't say you didn't, but she unmuted. I wanted to give her the option of speaking.
Blah, blah, blah. Okay, I don't get many things correct.
Get nagged.
Okay, your other people can be correct too, Valeria.
I don't... They are always correct. I'm never right.
Your point being?
Never mind.
So, as soon as you see a statement like that, you're using either MVT or IVT, one of those two. So, we have to know which one we're using and why.
Right.
So
why?
am I using MVT or IVT here?
I use the IVT, but I could be wrong.
Why would we use the IVT? What's the hint that we're using IVT or MVT?
Wait, what?
So what's the hint?
Is IVT just a value in between, like a set of points, and is MVT like a specific one?
No.
No.
Their setup is almost identical. There's one major difference between the two of them.
One's on an interval.
They're both on an interval.
And we'll just
Isn't IVT where it's like between just the regular functions, while MVT is between the derivative?
Not necessarily between, like you said, but that is the distinction there. IVT uses the function. MVT uses a derivative of some sort, so slope, so instantaneous rate of change, which is going to be part D. So we start using kind of the idea there for part D, which is where they start using the rates of change. So if we're looking at just the function and it having a value there, that's going to be IVT. If we were looking at a derivative value, then we'd be looking at an MVT. That's how you know the difference between the two. Okay, so what's the first thing I got to do for IVT?
Make sure it's continuous or something.
Very good, Miguel. We have to state and make sure it is continuous. So we have to be talking about G here. Is G continuous is the question. You can't just say G is continuous. Unless it's Deborah. That's
Yeah.
Deborah's phone.
Sorry, Mom texted me. She tried to call me.
Right, should have put her on speaker.
I can't answer that call and be on the call with you.
Oh, I keep forgetting you're on your phone, not on.
Yeah.
I just assume people are on their computers, even though only 3 people are. Everybody else is on their phone.
How can you tell?
In Discord, it tells me by the icon next to your name if you're on your phone or if you're on the computer.
You can do that? Oh, okay, never mind.
Yeah. All right. So, we do have to say it's continuous. Again, unless it's self-evident, you can't just say that G is continuous. This most definitely is not self-evident that G is continuous.
Self-evident, like they'll tell you?
Like it's pretty, like if it's a polynomial, you could say G is continuous, no big deal. Or if it told us that G was differentiable, then we would know G. We could say G is continuous because G is differentiable. It's a straightforward statement. This one actually is a lot more to it. So because G is a composition of functions of f, we have to mention f. So in order to get full points here, which I assume very few people did, you would have to say f is, you really should say twice differentiable, therefore f is continuous. That's the first part. Then you need to say G is a composition of continuous functions. Therefore, G is continuous. That's a terrible continuous, but whatever. So the second part there is going to be the hardest part of this to get that first point. Most people would not get this first point, I'm not going to lie. So since f is differentiable, it's quite easy to say f is continuous. No problem. However, in order to say G is continuous, you have to understand G is made up of a composition of functions. Remember back in like Algebra 2 where you did Fogg and Goff? So since we have a function inside of f, the x squared minus x, if that's continuous and f is continuous, then and only then G is continuous. And that is a hard extra point to get. So if this was given on like an AP exam, most students would miss that first point. So that part's the hard part of this question, to be honest. The IVT part, super easy. How do we evaluate and use IVT?
Well, you plug it in.
It is not a word we can use, you know that.
I don't know which one you plug it into. If
We plug in our endpoints?
Is it G?
So plug in the endpoints to G. So plug in 0 and 3 to G. So G of 0 is equal to f of 0 in this case, if I remember correct, which is equal to whatever. And then G of 3, which is equal to f of 3? Is it x squared minus 2x, right? Oh no, it's x squared minus x, so f of 6. And whatever those two equal, which are 4 and 7. So what does it mean that I got 4 and 7?
That there isn't about.
It doesn't exist or something.
Yeah.
What doesn't exist?
A value in that. What's it called?
Interval?
The interval?
Yeah.
Okay, so you're saying the answer is there does not exist a value in that interval.
No, not per se, but like, you know what we mean.
I know exactly what you mean. But however,
I just can't verbally explain it right now because I'm kind of retarded.
well, I can't grade on what you mean. We can only grade on what you write. So there's a distinct problem there when it comes to AP testing. In that I can't give you points on oh, he meant this. Because if you don't write it,
It's okay, you can.
no, I can't, and I won't.
Okay, then.
It also doesn't help that you're all wrong.
Okay,
Damn.
Okay, you're misusing the IVT. You have to remember, the IVT is not only for zeros. You were looking for one negative value, one positive value. It is not what we were looking for.
What else can you use it
Somebody, what else can we use it for?
What?
What else can we use the IVT for besides zeros? That is not the only use of the IVT.
Finding I don't know.
What does the IVT tell us?
So there are points
There's a point in
in an
between.
unknown interval.
So let's make it specific to this problem. I got g of 0 is 4, g of 3 is 7. What does that tell me about g using the IVT?
Between 0 and 3, there will be a value of 5.
That's not the only thing it tells me. We got to be careful not just answering the question. So I want a generic statement is what I was looking for, but that is correct. The IVT tells us since g of 3 or sorry, g of 0 is 4 and g of 3 is 7, the function g, since it is continuous, very important part, then it will take on every value between 4 and 7. That is what the IVT tells us. The most common use, and what you used it for in pre-calc exclusively for the most part, is the fact that if you get a positive and a negative, you have a 0. And that is a great use of the IVT. That is not the only use of the IVT. We have to remember it tells us it takes on every value between those 2 points. Now, could it take on values like, I don't know, let's say 10? Could a value be 10 in there?
No?
Oh,
The answer is yes, it could.
What? Wow.
Do you know what happens in between 0 and 3?
yes.
No.
No.
Well,
Do you know what g looks like? Do you know the function? Can you say for sure?
Oh, I guess it.
No.
no.
Never mind.
So 0, 4 is there, 3, 7 being roughly there. For all we know, we could have a couple different graphs. It could be a linear function, and it could just go right through all of them. You could also have something that's like a parabola, and you could do, or even a cubic function, do something like that, to where it takes on both values above and below the 4 and the 7. What the IVT does is guarantees it takes on the values between those numbers. But we don't know anything else other than it has to go through at least one of those. So if you look at the red graph I have drawn, the cubic looking one, that has every value between 4 and 7, but it also has extra values. We don't know if it has extra values or not, but we can guarantee that it has to have at least every value because the most direct route is the linear route. So that line has to take on every value between there. So now, as already mentioned, for part C, we can say that yes, there does have to be a value of C that is equal to 5 in between 0 and 3 by the IVT. Now you do not have to mention by the IVT. It is not a requirement to say IVT. So as long as you have that it's continuous, and you show that one value is below 5, one value is above 5, and then make this last statement, then you're perfectly fine. You never actually have to use IVT. So we get 4 is less than 5 is less than 7. Therefore, g of c equals 2. 2 equals 5 exists, where 0 is less than, not 0. 0 is less than c is less than 3. So you have to make that last statement as well. Now, you never actually have to use the words or letters, whatever you want to say, IVT. If you want to throw it in there, that's fine, doesn't matter. I always err on the side of caution and say don't use it, because if you use the wrong one on accident or something, you lose points. Any questions on that one? Okay. Part D, your answer, this is calculator active, so your answer should have been negative 1.863. Do I need to do this one?
Wait, what?
Answer should have been negative 1.863.
I think I got 8.
8's not even in the interval, sweetie. It has to be between -3 and 0. Oh, Deborah.
Actually, I just don't think I did that one. Oh, there it is. I just got really confused. So yeah, can you do that one?
Okay, so going over the problem, first things we gotta look at, because I'm sure you're not the only one. What is the instantaneous rate of change?
I don't know.
The slope at a point.
Okay, let's do a little bit better job of looking at this problem specifically. What is instantaneous rate of change?
Monkey.
Definitely not monkey.
I never
Just
know.
like specifically for this problem or just in general?
Well, in general, but I mean specifically as well. Like, you don't have to give me the exact thing, but what does instantaneous rate of change mean? So Thomas gave me a correct thing, but was not the one we should be using. So it's a slope at a point.
Derivative?
Tangent line?
That is the derivative. Very good, Miss Kayla. Whoever said tangent line, you got to be careful. It is the slope of the tangent line. It is not the tangent line. So you have to be careful with your wordings there. So very nicely, they gave us the derivative. That is the instantaneous rate of change.
Wait, what?
What do you
The
mean,
h
what?
prime of x?
Yes.
Okay.
And then they want the instantaneous rate of change to be equal to the average rate of change. What is the average rate of change?
FTC.
Do we agree with Kayla? Is it the FTC?
Probably.
Let's think. What unit are we in?
3.
I don't.
Oh,
We're in unit 3. This is most definitely not an FTC yet.
So is it
there's
the slope?
Is
You're
it the F
thinking-
of B minus F of A over B minus A? Or am I thinking the wrong thing?
but that's
Uh,
FTC.
That's
is
not
it.
FTC.
Oh.
You got to be careful when you say that. You have to distinguish between
Yeah.
capital F and lowercase f. And capital F, you're thinking of average value function.
Oh, okay.
So Miguel, you were correct, and I think Valeria, you said slope, so that was correct. The average rate of change is the regular slope, delta y over delta x, or much better written out as f of b minus f of a over b minus a, with lowercase f's. When we talk about capital F of b minus capital F of a over b minus a, that is then your average value. So you got to make sure you keep those two separate. So basically, they want you to set the derivative equal to the slope, so f of b minus f of a. So was it -3 and 0? So we want f of 0 minus f of -3 over 0 minus -3. What is, or sorry, h, not f. And I'm assuming they gave us those somehow. Oh no, it was f. That's okay. I was about to say. So, somebody tell me what is f of 0?
4?
F of -3.
Negative
About
5.
-5.
Over 3. So I get 9/3, which is 3. And then we
Then
want.
9/3 equals 3.
Did you just ask how I got 9/3 equals 3?
No. I'm being funny.
I thought it was a serious question. Sorry.
No.
And then we want that to be, so we want h prime of c basically to be equal to 3. Well, they gave us h prime, which is that ugly function. This is why you'll need your calculator, and I can pull up the calculator and show you how to do it in a second. 4e to the cosine x. So we get 4e to the cosine of c equals 3. And then we have to use the calculator to solve that. Okay. So there is one of 2 ways you can use the calculator to solve. Alright, so I'm going to graph it and show two different ways to do this. So the first one, for e to the cosine x. Make sure I am in radians. I am. And then 3. Refresh. Okay. So once you get your graph and you see this, notice how there's a lot of answers. How do I know which answer to pick?
The one on your interval.
So very good. When I go to my window, I can change this to be -3 to 0. And notice I am looking for where these two graphs are equal, so where the red and the blue line meet. How am I going to figure that out?
The intersection.
Very good. So calculate intersect, so number 5. It wants the first curve. I'm already on the blue curve, sure. Red curve, sure. No, I don't want to guess. And there's your answer. That's one option to find using intersections. The other option is to, remember, get it equal to 0. So it would have been 4e to the cosine x minus 3. I can then delete this. We'll still keep the window the same. And then I'm looking for my 0 at that point. So instead of calculating an intersection, I would now calculate a 0. And then do the left and then the right.
That's nifty.
You say that like I haven't taught you this.
Well, I'm now remembering it.
And then hit enter, and there you go. The nice thing about this, if you need help with that or to redo it, it's in the video stream. You can go back and pause it, and you can see my keystrokes on the calculator down at the bottom, so you know kind of exactly what I did. But those are the two different ways you can do that using a calculator, either through intersections of two curves or set it equal to 0 and solve for a 0. Those are both both applicable. No, whichever way you want to do it.
So for this question, what would you get points for?
This question points were awarded for finding the average rate of change, so doing the f of b minus f of a over b minus a, and then for the answer, basically setting them equal and solving.
Gotcha.
And remember, we round to how many decimal places?
3.
3.
Trace.
We're not in Spanish class. Okay. Any questions on that one? Okay. Moving on to part B then. Okay, did anybody have trouble showing the correct derivative?
Wait.
Well, I did, but now you showed us how to do it earlier, so fine.
I did.
Didn't you? Wait, isn't it the same kind of way that you did in the?
I mean, yeah, you have to use chain rule and everything.
Well, I didn't know how to do that at the time with like the f of x.
There's no f of x on this one, sweetie.
Oh wait, this is a different one. Never mind. I take it back.
Yeah.
Oh, wait. Let me pull it up so I can see what the answer is. Or what is the answer?
4 over 2y plus 1 all squared.
Okay.
Anybody
yeah, it told you that at the beginning, huh?
Yeah, it tells you to show that. Like, they give you the answer. You just had to get the work done. Which is not something I've ever seen on an actual AP test, so I doubt you'd ever see that. But it's also probably not going to be you taking a derivative of this on a free response question for real.
I think that was the only one I got right.
Yay, Larry got points.
Look at that.
Can you release the Unit 3 Part B too? Or are we not going over that today?
Do what?
The Unit 3 Part B.
That's what I'm going over right now, sweetie.
Yeah, but you didn't release it in AP class year.
Okay, I didn't score yours. I'm sorry. Deborah.
I know. I need to be able to see it up here though, or I get confused.
Then don't submit.
Oh.
I only need one person to submit.
Bruh.
And Alyssa's been kind enough to, it looks like, submit for me every time. So thank you, Alyssa.
Well,
You're
I
welcome.
find more.
Okay, I graded you all
Melissa,
zeros,
you
but
sound dead.
it won't let me submit for you, Deborah. Oh, because I gotta do number 2 as well.
Oh,
There, you now have all zeros.
that's what I have in the class. It's okay. Matches.
Technically, we haven't started the 4th quarter yet, so I'll just start you off with a
Good.
0.
Started?
Technically, no, because we haven't come back to school after spring break yet, sweetie.
But why is focus in the fourth quarter?
Because
Focus is
Focus,
computerized.
like literally the day after quarter 3 ends, it'll change to quarter 4. However, we just haven't had any school yet. Okay, so part A we're good on. Part B, I'll give you the answer, and then if you need me to go over it, which I'm assuming you do since it's a tangent line, you should have gotten for your tangent line y plus 2 equals 4/9 x plus 1.
4/9.
Yes, that's what they. All you gotta do is plug in the number to their derivative that they gave you.
Oh wait, I thought you had to do the opposite.
I
reciprocal,
did, but
so
I
looked
did
up.
something wrong.
You only do opposite reciprocal if you're wanting the normal line. Tangent line has the same slope as the curve.
Okay, got it.
So what did you get for your derivative, Kenna? Or your value, not the actual derivative, because I gave you that.
I got 1/4, and I don't know how.
Did you use their derivative they gave you above?
Yeah, I'm just stupid. I think I plugged in the wrong number. It's okay. I'll figure it out.
Did you plug in -2 for y? Because x doesn't even
Yeah.
matter. So you should add 2 times -2, which is -4, plus 1, which is -3. -3 squared is 9. 4/9.
Oh, I accidentally did 4 times 4. That makes sense.
Okay.
Yeah, you got it.
Okay. So should have been hopefully pretty easy to write that tangent line. Anybody need me to show anything? Okay. Part C. I'll give the answer and then I'm probably going to have to go over it. Part C should have been 64 over 243.
Jesus Christ.
That's what I got, and I was like, that's such a sus answer.
Is this calculator? Yeah, this is no calculator, so
How
make
did
sure.
you get the bottom part?
I
got
would
the
have.
No.
I would suggest you leave it as -64 over 2 times -2 plus 1 to 5th power. You should leave it like that, unless you just
No,
happen to know your 5th powers.
I
No,
forgot
I
the fifth
did the
power.
calculator.
Definitely took the derivative, but I definitely stopped there.
Yeah, please don't do that. Please plug in the point.
Oops.
So yeah, this is a non-calculator section. Keep that in mind. So I would definitely suggest that you leave it at -64 over. Even if you want to put it as what 3 to the 5th, -3 to the 5th, that's fine. But I would not suggest doing at a 5th power non-calculator unless you really, really want to do it for some ungodly reason.
I think I took the derivative wrong.
Your derivative should have ended up as -64 over 2y plus 1 to the 5th.
Yeah, definitely did that wrong.
Do you need me to do the derivative for you?
Yeah.
Okay, so it's 4 2y plus 1 squared.
Whenever I took the thingy that I used, the equation that I took the derivative of, I didn't use the one they gave us. I factored out, distributed the.
Oh Jesus, Deborah.
Well, I like looking at that better.
Because you're dumb. That is a very easy derivative to take if you move it up to the top as a negative exponent.
I
It
did
is
that.
not a quotient rule. Do not do quotient rule. I'm looking at a lot of you right now. So,
I moved it up, but I still
Not
did.
me.
So we take the second derivative. This second derivative is relatively easy, actually. So d squared y over dx squared. Bring the -2 down, so you get -8, 2y plus 1 to the -3rd. Don't forget the derivative of the inside, though, times 2y prime. And instead of saying y prime, since we're using dy dx's. So
I
don't
didn't
forget
do that
the
part.
chain rule. That's the part that most people mess up. That's where the 5th power comes in. When I substitute this into there, they'll combine to be -5th. So we get -16 2y plus 1 to the -3 times, was that 8, or times 4, 2y plus 1 to the negative second. The 4 and the 16, that comes to be the negative 64. I'm going to move all the negatives on the bottom and combine them to 2y plus 1 to the negative fifth. And then at that point, plug in your negative 1 and negative 2, which you really only plug in the negative 2. And then, like I said, I would definitely, on free response, leave it. Do not try to calculate everything out unless you really, really want to for some reason.
Okay.
Any questions on the derivative, or are we okay? All right. Part D. Ooh, they were nicer to you guys than they were to BC. So how are we going to find y inverse prime?
I've never guessed on a question more than I did in this one. I can't.
Literally.
If only there was a
I
formula
feel
we
like
had
it's
for
fine already, yeah.
inverse derivatives.
Yeah,
Yeah,
but
I
I
don't
don't
know
know.
what that is.
Didn't I just go over this like yesterday?
Yeah.
Y
Isn't
prime
it
of y
just
equals
g
1 over f
g
of
prime
x
of x
prime.
equals 1 over the derivative of f of x?
Yes.
That's crazy. I
But
So,
I just really don't understand how to use that.
not negative 1. So if I do the inverse derivative of 0, it's 1 over y prime of something. What is the something that goes in there, though? We have to remember, what does that 0 represent on the inverse function?
A y value.
Y value.
So what has to go into the original function?
An x value.
Not just an x value, but the x value that goes with the 0. Well, what's my x value that goes with 0?
1/2.
1/2.
That says
No,
1/6.
Sorry.
I thought it said 6 when I looked at it, but I agree. I just was like, all right, cool. I know Thomas can't read, but I thought he could read numbers. God.
I'm sorry, I don't have my glasses on right now.
Okay. So that is just using the inverse derivatives and remembering that that is how that property works. And then at that point, you just do y. We need y prime of 1/6. So our y prime was 1 over. So let's see, what was y prime? The derivative was 1 over 2y plus 1 squared, right? No, it was 4 on top, wasn't it?
Yeah, 4 on top.
Okay, so 4 over. What's going to go on the bottom?
4?
What do I do with that on the bottom? What's going to go in the parentheses?
The same thing that went on the parentheses earlier?
I don't know what that is.
2y plus 1.
Well, I'm
right?
plugging in values at this point.
Oh. Well, y is 1/6.
Y is not 1/6.
0.
Y is 0. They were trying to trick you.
I don't like that.
I don't care. So you have to be extremely careful with that. If you're not paying attention, you will put in the 1/6 for the y value, and the y value is not 1/6. The y value is 0. So now we can plug this in up there, and we get that y inverse prime of 0 is 1/4. This is not a very difficult question, but there's definitely room for a lot of easy mistakes to be made if you're not careful. Any questions on anything I did anywhere?
Well, I got 4.
For what?
The actual answer,
Well, then you're wrong.
I was kind of close, though.
Sure, we'll call that close. Okay, that one, let's see, that last part's definitely tricky. I'm not gonna try to even hide that. They're trying to, not necessarily trying to trick you, but they're really trying to see who's paying attention.
Not me.
Okay, question number 2. I think this was the easier one, if I remember right. That's not too bad.
It felt good.
Alright, so answer for A should have been negative 10e over 3. Do I need to do that one?
Yes, I got it.
There, we're finally got something right. Anybody else? Do I need to do that one, go over that one, do anything with it? Okay, I'm going to take that as a no. Everybody's good on that one. Okay, part B, your answer should have been 2/3.
I got that one right too.
Small miracles do happen.
They do.
Can you go over that one?
Yeah, I can. So f of negative 2x. Okay, so if we want h prime, we have to do multiple chain rules here. So what the first function is going to be my f, so I'm going to take the derivative of that, so it's f prime. Leave the inside alone, so leave the f of negative 2x alone. Then my next function is again f, so f prime. Leave the inside in this case, which is the negative 2x alone, and then times the very last derivative of the inside, which is negative 2. And then from there we plug in our, what value are we doing? 1. So we plug in 1. So h prime of 1, f prime of f of negative 2, times f prime of negative 2, times negative 2. And what is f of negative 2, somebody?
Negative 3.
And what is f prime of negative 2?
1/3.
And what is f prime of negative 3?
Negative 1.
So any questions on anything I did anywhere there?
No.
And then part C, your final answer. Oh, this is not a pretty answer. Pi over 5, negative pi over 5 minus 2 over root 3.
I don't know. I left it in like some version of expanded form.
Okay, so let's see. So what I would say is calculate it, and I'll get an answer real quick of what it is.
Okay.
Negative pi divided by 5 minus 2 divided by... So if you want to check your answer to see if it's some other version, your answer should be negative 1.783.
I got that.
Oh my god!
Wait, what was it?
Negative 1.783.
I got positive 1.783.
I've never been more excited in my life.
Everything should have been negative, so negative pi over 5 and negative 2 over root 3. And good job, Larry.
Thank you.
Oh, hold on.
Does anybody need me
Oh,
to do
that's
this
why.
one?
I figured it out.
Okay. Does anybody need me to do this one? How many of you are AFK right now? In case you don't know what that means away from the keyboard.
Wait, I definitely
I'm
did
not.
it wrong.
I'm here.
I got it
We're
right
all
when I
here.
had this other. I don't know. Hold on.
I'm here.
Was that English,
Shut
Will?
up, Thomas.
No,
Will's probably still asleep.
That's why I was wondering.
a little
I
bit.
dropped a negative somewhere, but I don't know where.
Don't know. Probably arc sine of negative 1/2. You probably made positive pi over 6, most likely.
Well, my negative or my 1/2 was positive, but then when I put in a negative 1/2, it gave me like 0.5.
Huh? Are you in radians or degrees?
Radians.
Okay. Well, you shouldn't have been using a calculator anyway. This is a non-calculator question. So I don't know, because f prime
Wait,
of...
let me try this. Okay, there it is. I needed to subtract my other thing because I had it added.
Okay.
I figured. I had 2 negatives though, so mine canceled out into a positive.
The only thing that should have been negative should have been your arc sine value and your f of negative 1. Everything else should have been positive everywhere.
Well, I had f of x as like my second term or whatever, and f of x times the 1 over square root of 1 minus u squared or whatever times u prime. Oh, I didn't take the derivative of that, I don't think.
Okay. U prime should have been 1/2. I think.
Yeah. Negative 1/2.
Positive.
Why?
Because...
Oh. Okay, so mine was negative.
You're plugging in negative 1, but that value is still just the derivative of x over 2, which is just positive 1/2.
Okay.
So you don't plug in. Yep. Okay. Anybody else have any questions on that one? Like I said, a lot of silence. Just want to make sure people were there. So I appreciate the answers.
Left it with everything plugged in.
Yes, I would highly suggest that. The only thing you can't leave in your answer is like f prime of negative 1 and f of negative 1. But I highly would have suggested you would have left your square root alone. I suggest you wrote arc sine of negative 1/2, all that kind of stuff. Things that definitely do not evaluate those unless for whatever reason you really want to. And even then, don't do it.
We don't have a calculator, so it's kind of impossible.
No, it's not.
Well,
they're easily simplifiable, but...
Well, I don't want to do the square root of 3/4.
No, I'm saying don't leave it as arc sine of negative 1/2. Like leave it there. Don't tell me what that is. Don't even simplify it to 3/4. Leave it as 1 over the square root of 1 minus negative 1/2 all squared.
Okay.
Like leave that alone. Do not modify that in one bit, because if you make an algebra mistake, then you are screwed. So don't. Just leave it just like that, and it's actually preferable for the readers because that means we don't have to check anything. We just look and see you did all that. Cool, you're done. You stopped as a smart person. All right. Any other questions on any of these? All right. Then you guys are good to go. I will be assigning unit 4 here in a little bit.